Our notes today are 7-2, similar polygons. And similar is a new word that we actually all just learned about, so we're just going to extend our knowledge about similar polygons now in some more focused notes. Today's video is dedicated to the girls lacrosse team. You can even see the Preuss School back here, so this is actually our Preuss lacrosse players right there. Today's notes, we're going to write something very short at the very top of our notes, and you have a large glue-in, and we're going to be writing stuff inside of those glue-ins, and that's really all of our notes today. Now, we actually just learned about similar polygons, but I wanted to go over a couple important things. The first is that this little curly symbol, it represents that two things are similar. So for example, if you wanted to say that a triangle was similar to another triangle, then you would put this shape in between the two triangles. Now, what do similar polygons have? Well, there are two things they have to have, and this is really the only big things that we're just reiterating in our notes that we've already written down. Similar polygons have, one, corresponding angles, that are congruent. And I really want you to underline this. This is really important. The corresponding angles are congruent. The sides, the corresponding sides, are not congruent. The corresponding sides are proportional. And those are really the two major requirements that you have to see in order to say that the two shapes are similar. So go ahead and make sure you underline congruent and proportional. And if you have a marker, let's go ahead and underline angles and sides as well so we can see that. That's really the only big notes we're going to be writing today. Okay, we're going to start by just looking at the top section of that table. And because this table is a little small for me, I'm actually going to go section by section, starting with the first diagram. The purpose of this section is to ask you to take a good look at two similar shapes. This quadrilateral is similar to the next one. I'm going to go ahead and put that shape there, that symbol. Put the symbol here so that we know that this quadrilateral is similar to this one. Now for this table, they're asking us to find the scale factor from this bigger shape to this smaller one. And lastly, to find any missing sides on those two shapes. All right, the first thing we're going to do, which I hope you noticed, is that I color-coded all the corresponding sides. Here, this last one was blue corresponding sides. I did this because in order to find the scale factor, I need to find two corresponding sides that also have numerical values. Now my red sides are 12 and x, my orange 9 and 6, my green z and 3.5, and my blue y and 6. The only two sides that are corresponding that have numerical values are 9 and 6. So that means that my scale factor, my k, is 9 over 6. Now you could have chosen to write k equals 6 over 9 if you chose to switch these around. That would be fine. The only thing that you need to keep in mind is whichever way you decide to write your scale factor, just make sure that you remember the way that you're going. Here's what I mean by that. If I say the scale factor is 9 over 6, then that means I'm looking at the big shape to the small shape. I'm going to write big and small. I can kind of tell that without writing it because obviously 9 is bigger than 6. If you had chosen to write 6 over 9, then you would have to remember that the scale factor is looking at the smaller to the bigger value. What exactly in your ratio does the numerator and denominator represent? So keep that in mind. The one thing that does matter is you do have to simplify your scale factor. So in this case, my scale factor isn't 9 over 6, it's actually 3 over 2. Now, how are we going to find those variables? One thing that was suggested to me is that I have more steps. So for finding the variables, here's some things that I would do first. First, you need to find the scale factor because you need the scale factor to set up a proportion. Now on the proportion, remember proportion is two ratios equal to each other. So that means that one of them will be the scale factors equaling another fraction, another ratio. And where does that ratio come from? From two corresponding sides. Now they asked us to find all the variables. I'm going to go in alphabetical order, starting with x. My x value is red, so when I look there, my bigger value is 12. My smaller value is x. That means that my proportion is 3 over 2 equals 12 over x. I'm going to go ahead and cross multiply to get 24 equals 3x. Divide by 3 on both sides to get x equals 8. The next variable we're going to find is y, and that's blue. So again, I'm going to set up my proportions. 3 over 2 is the ratio that it's increasing. And my values are y and 6. Y over 6. I'm going to go ahead and cross multiply to get 2y equals 18, or y equals 9. The last value I'm looking for is z. So again, my scale factor is equal to whatever the corresponding sides are, in this case z and 3.5. And again, I'm going to cross multiply to get 2z equals 10.5. Divide by 2 on both sides to get z equals 5.25. Using those 3 steps, I was able to find those 3 missing variables. For this second question in this diagram, what I'd like you to do is again note that these two triangles are similar. I'd like you to find the scale factor and to find all those variables alone. Pause the video, and when you're ready, unpause it to see if you were right. The scale factor in this case is 15 over 30, because those are the corresponding sides in red that have 2 measurements. And when you simplify that, your k is 1 over 2. You may have written your scale factor as 2 or 2 over 1, which would be correct. Now, for this specific example, I need to find x and y. I'm going to go ahead and write my scale factor twice. My x value is orange, and I'm going from small to big. So x over 25.5 is my first ratio. And green is y over 37. From here, I'm only going to solve by cross multiplying to get 2x equals 25.5. Divide by 2 on both sides to get x equals 12.25. And on my second proportion, cross multiply to get 2y equals 37. Divide by 2 on both sides to get y equals 18.5. And those are my 2 missing variables. In this bottom section of the table, it's asking something different. They've given us 3 different diagrams, and of those 3 diagrams, they haven't said that they're similar. In fact, they're asking, are these triangles or quadrilaterals, are they similar? Yes or no? And then if they are, tell me why, and give the scale factor, find k. Of course, I couldn't have a Girls Across video without Miss Hawk, so hi Miss Hawk. And next to Miss Hawk is a reminder of the notes that we wrote for similar polygons. If 2 shapes are similar, they have to meet these 2 criteria. The corresponding angles have to be the same, and the corresponding sides have to be proportional. So let's go ahead and check the first one. And I'm going to actually move this, there we go. Okay, we're going to start by looking at these first 2 triangles, and we're going to check first the corresponding angles. Now I know that these 3 angles are congruent, and because of these arcs here, I know that this angle is the same as this angle, this angle, this angle, this angle, and this angle, because the notation says so. These are equilateral triangles. They all have the same sides. That means the angles are all 60 degrees, so the angles are all congruent. But are the sides proportional? Well, we got to check every corresponding side. AB corresponds to FE, 9 over 15, 9 over 15, 9 over 15. All the ratios are the same, therefore they are proportional. So my answer is yes, they are similar. Triangle ABC is similar to triangle FED. Why are they similar? Because the corresponding angles are congruent and the corresponding sides are proportional. And what's that scale factor? Well, we said it several times. 9/15 is the ratio we saw, and this actually can be simplified. Divide by 3 to get 3/5 as my final scale factor. Now for my second two triangles, it's a little bit trickier because they took this triangle and rotated it around so the right angle's here. So let's check again. Is it similar? First, are the angles congruent? Okay, right angle, right angle. This has one arc, that has one arc, so those two angles are congruent. Two arcs, check. The angles are congruent. Now, are the sides proportional? The height of the triangle is 16. The height of this triangle is 8. So 16/8. How much less is 16 to 8? It's half. The hypotenuse of this right triangle is 34. The hypotenuse of the smaller one is 17. 34 in relationship to 17, 34/17 is a half again. JL is the bottom leg. RP is the other. 30 to 15. 15 is half of 30. Yes, they are proportional. So my answer for this one is yes. Triangle KJP. Oops. KJ. Oop. Where's my eraser? Sorry. KJL is similar to triangle QPR. The reason being that the corresponding angles and the corresponding sides are congruent. The corresponding angles are congruent and the corresponding sides are proportional. Now my scale factor disappeared here. I'll write that again. My scale factor was 3/5 and my scale factor here was 1/2. Now what I hope you notice is if I say the K value is 1/2, then I'm referring to this small triangle to the big triangle. You may have written the K value as 2/1, but what I hope you remember is both of these are correct. It's just a matter of choosing one over the other. I'd like you to do this last column by yourself, this last row by yourself, and that's it. Good luck.